All right, good afternoon to everybody. We're going to be doing analyzing equivalent expressions, practice and problem solving. Let's do number 7 to start off with. Eric is planning an event at a hotel. Let G stand for the number of Eric's guests. Okay, the two expressions represent the difference between the cost of the rooms. Expression 1 is, looks like 326 plus 37G, and we're going to minus 287 plus 23G. Okay, and if we do that, it says expression 2 is 39 plus 14G. So this is expression 1. And this is going to be expression 2. That's it, 39 plus 14G. What can you tell us about expression 1 and expression 2? Well, to do this, first we got to go ahead and solve expression 1 to see if it has any characteristics equivalent to expression 2. When I subtract this expression here, I have to turn all of my terms to the opposite symbol. So this would be negative 287, and because a negative times a positive is a negative, and then a negative times a positive 23 will be negative 23G. Now I got to put my terms in columns over here. So this would be negative 287. And this would be negative 23G. All right. So now when we do this, I see that I've got 7 minus 3, that's 4. And I got 3 minus 1, that's 1. And since they're G's, I put a G at the end. And since the bigger number is positive, that gives it a positive number. Over here, I see that I've got to borrow to go ahead and subtract. And when I do that, I have 16 minus 7, which is 9, and 11 minus 8, which is 3. And now, as we can see, when it says, what can you tell us about the expression 2 and 1? Well, both are equivalent, right? Both are equivalent to each other. Okay. Oh, I'm sorry, I misspelled equivalent, didn't I? Equivalent. Sorry. All right. Let's go to number 9 now. Number 9 says, Kiriana buys boxes of crackers that each have the same cost. C. She represents the cost of 3 boxes of cheese crackers, 2 boxes of poppy seed crackers, and 2 boxes of plain crackers using the expression 3C plus 2C plus 2C. What equivalent expression can represent the cost? Well, if we have the expression 3C plus 2C plus 2C, I can go ahead and say that 3C plus 2C is 5C. Now I have 5C plus 2C. See, I grouped these two together and added them. But now, because I added them because they had the same variable to the same power, C. So they were like terms, and that's why I could get 5C. But I see here I also have 2C with this 5C, both of them again, and with the same variable. So I can add these two as well to equal 7C. So the term 7C would be equivalent. Now let's go to number 11. Number 11 says, a farmer recently sold a large plot of land. The sale decreased his total acreage by 8%. Let V be the original acreage. Find two equivalent expressions that will give the new acreage. Well, the first one I can think of it is because if I take any percent and I want to turn it to a decimal, I can move my decimal spot 2 spaces and it becomes a decimal. So that means if the farmer, let's see, we're going to let V be his original acreage, so that's V, and we're going to have to minus 0.08V from that amount to get us our answer, right? That's one expression. The next one, I could go ahead and say, well, let's solve this. Remember, there's a 1 in front of every V. So 1V minus 0.08. Well, both of these are like terms, so I'm going to be able to say 1 minus 0.08. Well, if I line up my decimal point, that's going to give me 0.92. And so my new expression could be 0.92 V. So there's expression 1. Find two equivalent expressions. There's 1, and the second one is 0.92 V. B says use the expressions to describe two ways to find new acreage. Well, I could, I'm going to type this out because it'd be quicker. I could multiply the multiply V, whatever V is, to 0.92. That would get me my acreage. Or I could multiply V to, I should say by, um, 0.08. I could just put 0.08 really. And subtract it from V. And I guess I should put, instead of it, I should put the product from V. The product being the answer to the multiplication problem, V times 0.08. And it looks like this point should have followed along, but it didn't know it should. All right? And that would be my answer. Let's go to number 13. The area of a rectangular playground has been extended on one side. All right? So I have a playground, and it's a rectangle, and it's been extended on one side. All right? The total area of the playground in square meters can be written as 352. So I can put 350, let's see, 352. And I can go ahead and say this is 22 I'm sorry. Total area of the playground. Oh, I'm sorry. They're giving me the whole expression. The area, right, in square meters would be 352 plus 22x. And write an expression to give a possible set of dimensions for the playground. So I'm trying to find the length and width of this playground. Okay? So let's see what we can find out. Well, first I need to see what factors into 352 and 22. First of all, I'm going to see if 22 fits into that. Let me get my calculator out here. And if I do this, I'm going to take 352 and divide it by 22. And that'll give me, oh, well, that doesn't work. So I'm going to have to see what factors into both here. How about 11? Does 352 divided by 11 work? That gives me 32. So I'm going to divide both of these by 11. Okay? If I do that, I've got 11 times, oh, I didn't remember to write that answer down. 352 divided by 11 will give me 32. So 11 times 32 plus 2x. I'm just going to make, something seems wrong here. And that's because I see that 32 and 2 are both divisible by 2. So I'm going to check one more time. 352 divided by 22. I'll look at that. That equals 16. That makes more sense. Okay. So let's erase this. And we're going to put 16 here. Actually 22. And we say that 22 times 16 will equal 352 plus x. Does everyone see how we got that? Because 22 times 16 is 352, and 22 times x is 22x. Now, if I wanted the possible dimensions, I would say that this was 22, and this must be 16, and maybe this over here is x. Okay? So 16 plus x would be on top, and 22 would be over here on the side. Okay? And that would mean the area of this particular playground is 352, because x times 22 is the new dimension, the extension on the playground. All right, let's go on to number 15, high order thinking. Number 15 says a customer at a clothing store is buying a pair of pants and a shirt. The customer can choose between a sale that offers a discount on pants or a coupon for a discount on the entire purchase. Let N represent the original price of the pants and S represent the price of the shirt. Okay, it says write two expressions that represent 15% off the sale of the pants. Well, they said that N is going to represent the original price of the pants. So if that's the case, this is going to be N minus 0.15 N, right? Because the pair of pants is one pair, and I have to subtract 0.15 from it. Another way of doing this is to realize that I'm taking 1 and minusing 0.15 from that. That's going to give me 0.85. Which means another way of writing this could be 0.85 N. Now it says, write two expressions that represent off of pants. Let's see. Customer can choose between a sale offer of a discount of pants or a coupon, discount of the entire purchase. Let N represent, okay, the customer is buying a pair of pants and a shirt. So I have to add onto this the shirt, which is S, plus S. I don't know what the price is yet, but I do know that I'm going to have to add S to it. All right, now let's try B. Write two expressions that represent, and both of these expressions are equivalent, okay? This is expression 1, expression 2, they are saying the same thing. Write two expressions that represent 10% off the entire purchase. Oh boy. Well, in this case, I can say that I have, let's see, I'm going to take N plus S, and I'm going to minus 0.10 times N plus S. Okay? That's saying the price of the shirt and the pants, I'm going to deduct 10% off. Remember, we can find the percent, what the decimal is from a percent, by taking the percent away, like in 15% here. I'll take the percent away, and I'll move my decimal spot 2 spaces, and now that reveals to me what it will be as a percent, 0.15. In this case, 10% turns to 0.10. Okay, so that's why I said we'll subtract 0.10 times whatever the amount is. Another way to do this is to realize that I have one whole amount here, and I'm going to subtract 10% from it, which is 0.10. And that's going to give me 0.90. So I could also say, this is one expression. The second one would be to write that I have 0.9 N plus S. All right, C says that if the original cost of the pants is $25 and the shirt is $10, which option should the customer choose? So we're going to plug it into both of these formulas. I'm going to use the smaller one here instead of using the bigger formula. So the first one is 0.85 N, so I can say 0.85. Well, the pants were N, so that would be 0.85 times 25. And then we would add the price of the shirt, and they said the shirt is $10. Well, if I did this, 0.85 times 25, let's see, 0.85 times 25 equals 21.25. So this is now going to be 21.25 plus 10. And that's going to equal 31.25. Okay. Now I'm going to go ahead and check the other scenario where I'm going to have, let's see, 0.90 times, well, N plus S, that's going to be 25 plus 10. Well, if I did this, I'd have 0.90 times 35. And we can find out what that is. 0.90 times 35. I think I did something wrong there. Let's see if we said 0.90. Oh, boy, did I really mess up there. 0.90, minimize, 0.90 times 35. $31.50. Okay. Okay. So if I use the second expression here, I'm going to be paying more than I would up here. So it seems to me the better deal is the 15% off of the pant sale is going to be the better deal. All right? And that's all for tonight. Good luck with the ones you have to do, and I'll see you in class.